So today we're going to continue on with the prerequisite chapter. We're going to cover section 3. We're going to be learning about polynomials and special products. The first thing we're going to talk about is adding and subtracting polynomials. Whenever you add and subtract polynomials, really all you're doing is combining like terms. So each term, without looking at the coefficient, they have to be like. So for example, if I wanted to add 2x plus 3x, these are like terms because they both have the variable x, and then I just add the coefficients. If this were 2x plus 3x squared, these are not like terms, and that would be as simple as I could leave that. So let's go ahead and try some examples of adding and subtracting. So the first one is an addition problem. Now again, remember when you're adding like terms, you're only adding or subtracting the coefficients depending on the sign. Now for this one, since it's addition, what I can do here is I could drop the parentheses or you could leave them, but what I'm looking for are like terms. So I have a 4y squared plus a negative 7y squared. Once I combine those like terms, I get negative 3y squared. I do not add the exponents. I'm only adding coefficients here. Then the next one I'm going to look for is the next set of like terms, which are my constants, negative 3 plus 9, and this gives me positive 6. Now, technically, the order doesn't matter when you do this. But generally what we're going to start seeing is what's called standard form. And standard form is written with the largest exponent down to the smallest, and then the constant is always last. But technically, if you would have written your answer as 6 minus 3y squared, technically that is correct as well. But again, this is where you're going to read the instructions on WebAssign, how they want the answer entered. If it says standard form, then you're entering it this way. For the next one, still an addition problem. All we're doing is looking for like terms. So I have a like term here, 5x to the third power, as well as this x cubed. Now this x cubed has an assumed 1 here. So this is 5x cubed plus 1x cubed, which is going to give me 6x cubed, or 6x to the third power. Next, I'm going to look for another set of like terms. I'm going to do my squared terms. Negative 7x squared plus 2x squared gives me negative 5x squared. Next, I'll look for another one. I now have, if I want to write this in standard form, I'm going to go ahead and look to see if I have any x terms, which I do. There's nothing to combine with it, so I'm just going to rewrite it here. And then lastly, I will look for my constant, and I have a negative 3 plus 8, which gives me 5. By doing this and putting it from the largest exponent, which was x to the third, then x squared, x, and then the constant, it is now in standard form. The next one is a subtraction problem. And we need to be very careful when we subtract polynomials. What I like to do is something that I used to teach when I taught adding and subtracting integers, keep, change, flip, or stay, change, change. So what I do is I keep the first polynomial the same. So the first parenthesis stays the same. And then I change this subtraction sign to addition, and then I flip all of the signs in the second parentheses to opposite of what they are. So this will become a negative x squared, a positive 2x, and a negative 1. Because what ends up happening is everybody always remembers to subtract this first term, but then they forget about the other ones. So if you go ahead and do a keep, flip, change, or you could also think of distributing this negative sign to each of the terms, you can also interpret it that way. But I like to think keep, flip, change, and now I can go back and look for my like terms. So I have like terms here with the 2x squared plus a negative 2x squared, and this could be an assumed negative 1x squared. Once I combine those, I just get x squared. Then I'm going to go back. I'm going to look for, I want to write it in standard form. So I'm going to just grab my x term here, which is the 2x. Now, what's nice about doing the keep flip change, the 2x has the appropriate sign. If you didn't do the keep flip change, you might have thought that that should have been a negative 2x. But once we did the keep flip change, it's now a positive 2x. And then now I'm going to combine my constants, but it's positive 1 minus 1, and that's 0. So I don't need to combine anything there. So my final answer is just x squared plus 2x. All right, next one, same thing. I'm going to do keep flip change. So I'm going to keep my first polynomial, the first parenthesis, the same. So 7x to the 4th minus x squared minus 4x plus 2. I'm now changing this subtraction sign to a plus sign. And now all of the terms in the next parenthesis go to opposite. So it becomes a negative 3x to the 4th, a positive 4x squared, and a negative 3x. So all of these go to opposite signs. Now I go back and look for my like terms. I have like terms here with the 7x to the 4th and the negative 3x to the 4th. Once I combine those, I get 4x to the 4th. Again, remember, you're only adding the coefficients, and in this case, we subtract because one was negative. I do not add exponents here. Next, I'll look for my like terms and I don't have any x to the thirds, so I'll go right to the x squared. So I have a negative, and you can assume a 1 here, a negative 1x squared plus 4x squared gives me positive 3x squared. Then I'm going to go back now and grab my next like terms, which will be the x's. So negative 4x minus 3x, and that gives me negative 7x. And then lastly, the constant, nothing to group with it, so just plus 2. And I'm done. The next one has brackets and parentheses. So again, I would keep this one the same. Then I'm going to change this to a plus sign, but I need to simplify this thing first. I need to combine any like terms before I distribute or change the signs. So let me go ahead and combine these like terms first. So this would become y squared plus 3y minus 6. Now I can change all the signs to opposite. So then this would become, let me just go ahead and keep this. So 3y plus 1, and it's still a minus. Now I'm going to do my keep flip change. Keep it, y to the third plus 1, change it to plus sign, and now make all these signs opposite. And now I can go back and combine my like terms. So now I have nothing to combine with the y to the third. So I'm just going to write it down. My y to the square, my y squared, nothing to combine with it. But since I did the keep flip change, it's got the appropriate sign. And then nothing to combine with the y term, so negative 3y. But I do have my constants that I can group, plus 7. So next is multiplying polynomials. So when you multiply polynomials, you're going to multiply the coefficients. When you multiply variables with the exponents, remember you add them if the base is the same. And then when you multiply two binomials, you can either use distributive property or you can use the acronym FOIL. And then after you FOIL, you may have to combine some like terms. So let's try some examples. So for the first one, it's just straight distributive property. I need to distribute the x to each one of the terms in my trinomial. So I'll distribute x to 3x squared, and it gives me 3x to the third power. Next, I'm going to distribute the x to the negative x, which will give me a negative x squared. Then lastly, I need to distribute the x to the positive 1, which just gives me positive x. And my answer is in standard form. No like terms to combine. These all have different powers on the x's, so that is in simplest form. For number 7, I'm going to do exactly the same thing. I need to distribute the negative 3x to the 5, which gives me negative 15x squared. Then I'll distribute the negative 3x to the positive 2, which gives me negative 6x. Going to do the same thing on number 8, but this time I'm distributing a y squared. So y squared times 4y squared. Again, we're adding the powers on that y, so 4y to the 4th. Then I need to distribute it to the 2y. This will give me 2y to the 3rd. Remember, this has an assumed 1. 2 plus 1 is 3. And then lastly, distribute the y squared to the negative 3, which gives me negative 3y squared. Now, even if your monomial or your term is written in the back, you're still distributing. So you can either think of it as distributing 2 to the 2y to the 3rd, which gives you 4y to the 3rd, and then distribute the negative 3y to the 2y to the 3rd, negative 6y to the 4th. If you would prefer to put the 2y to the 3rd in the front and then distribute it to the binomial, you can. It doesn't matter. Now, this is not in standard form, so if the instructions say standard form, you would need to put the y to the 4th first, and then the 4y to the 3rd second. So either answer is acceptable on the test next week, but if the instructions say standard form, then negative 6y to the 4th would need to go first. So the next slide, we have a set of 4 problems, and they all have binomials in them. Now, when you multiply 2 binomials, you can either just use distributive property, or you can use the acronym FOIL. And the letters in the word FOIL tell you what terms to multiply. So the F is for first, the 2 first terms in each binomial. The O stands for the outer or the outside terms. And then the I is for inner or inside. And then the L is for last, the 2 last terms. You can use the acronym or just distribute. So when I do the first one, x times x gives me x squared. Then I'll do the 2 outside terms. X times 4 gives me 4x. Then the 2 inside or the inner terms, negative 8x. And then finally, the last, which would be negative 32. When you FOIL, majority of the time, you're going to end up combining some like terms. So in this problem, I can combine the 2 middle terms. 4x minus 8x will give me negative 4x. Nothing else can be combined. I don't have any other like terms, so my answer is a trinomial. I'll do exactly the same thing on number 11. I'm going to FOIL, or distributive property. So 3x times 5x, 15x squared. The outer terms, 3x times 7, 21x. The 2 inside terms, negative 2 times positive 5x is negative 10x. And then finally, last, gives me negative 14. Again, I can combine the middle terms here. That'll give me an 11x. And then drop down the 15x as well as the negative 14. Number 12, same thing. We're just distributing or FOILing. So first, 2x times x, 2x squared. The outer gives me 2x times 5 is 10x. Inner or inside, negative 4x. And then last, negative 4 times 5, negative 20. Again, group your middle terms. They are like terms. So this would give me 6x and then minus 20. Number 13, exactly the same thing. I'm going to distribute or FOIL. So first, 7x times 4x, 28x squared. Then the outer 7x times negative 3, negative 21x. The 2 inside, negative 8x. And then finally last, which is not going to show up, do it in red, will give me positive 6. I can group my middle terms here. So 28x squared minus 29x plus 6. And I'm done. So when you're multiplying two trinomials together, no acronym here. We just have to distribute. Now, what I like to do on questions like this, instead of putting them all straight in one line, after I distribute each term, I like to do it like in 3 different lines. So for example, when I do the first one, I'm going to be distributing x squared to each one of the 3 terms in the polynomial. That's the trinomial that's next to it. So x squared times x squared is x to the 4th. X squared times the 2x, 2x to the 3rd. X squared times the positive 2, 2x squared. Now, for the next one, instead of continuing on and writing the next distributed terms, I'm going to go down to the line below it. I'm going to distribute the negative 2 to the x squared, and I'm going to write it underneath. This is going to give me a negative 2x to the 3rd. This is going to make, when I go to add my like terms, a little bit easier. Everything's going to be lined up nice and pretty. Then if I go ahead and distribute the negative 2x to the positive 2x, this is going to give me negative 4x squared. And then negative 2x to the positive 2, negative 4x. Next, I'm going to shift to the next term, which is the positive 2. It needs to go to all 3 terms in that trinomial. So 2 times x squared. And again, I'm lining up my like terms. So notice how I shifted over a spot. Then when I distribute the 2 to the 2x, this gives me positive 4x. And then lastly, 2 times 2, and I get 4. Now I can add up my like terms up. So this should be positive 2x. 2x times x squared, that should have been a positive 2x. All right, now I can combine my like terms straight up and down. So I'm going to add nothing to add to the x to the 4th, bring it straight down. 2x to the 3rd minus 2x to the 3rd, nothing here, that's gone. Same thing on the next column. There's nothing to combine because 2 minus 4 is negative 2, plus 2 is 0. So all of these leave you with 0. Same thing here. Negative 4x plus 4x is gone. Nothing to add to that positive 4 at the end. So the answer here, after I multiplied, is x to the 4th plus 4. I'm going to do exactly the same thing on the next set of trinomials. Again, I'm going to write it. Now, if you would have preferred to write it all on one line and then go back and look for your like terms, you can do it that way as well. It's totally up to you. But I like to keep them lined up. It does make it a lot easier once you go to group your like terms in the end. So for the next one, again, I'm going to distribute 2x squared to all 3 of these. So 2x squared times x squared is 2x to the 4th. 2x squared times 3x, 6x to the 3rd. 2x squared times positive 2, 4x squared. Next, I'm going to be distributing the negative x to all 3. So negative x times x squared gives me negative x to the 3rd power. Negative x times 3x, negative 3x squared. Negative x times positive 2, negative 2x. And then lastly, I'm going to distribute the positive 4 to all three. So this will become positive 4x squared, positive 12x, and then positive 8. And now everything's lined up nice and pretty. Add them up. Nothing to add to the 2x to the fourth. Bring it straight down. I can assume a 1 here. 6x to the third minus 1x to the third is going to be positive 5x to the third. And then I'll add up the next column. 4x squared minus 3x is 1x squared plus the 4, and I get 5x squared. Negative 2x plus 12x is 10x. Nothing to add to the 8. And I'm done. The next slide has some special products. Now, the first one, when you multiply the exact same numbers or terms, but one's an addition binomial and one's a subtraction, what results is the difference of two squares. So this product is called the difference of two squares. More specifically, they'll be perfect squares. These next two bullet points, these are both binomials, and they're binomial squared. So if they ever say you have a binomial squared, the result or the answer to a binomial squared is always going to be a perfect square trinomial. Just be familiar with these terms. I'm not going to test you on vocab, but if you ever see something on a standardized test. Now, when we're dealing with that binomial squared, you're either going to memorize the pattern, or what I highly recommend you do is just write it twice and FOIL it. Because the common mistake, and I'm going to show you when we get one with some numbers, that students are going to make is they're going to think they could just square the A and the B, and that's their answer, and they miss out on the middle term here. So you're going to either memorize the pattern, or you will write it twice. Like, for example, A plus B squared. The best thing to do, write it twice and FOIL it. Then the bottom ones are binomials cubed. They're raised to the third power. Now, you can either choose to memorize the pattern on this one as well, or whenever you have a binomial, two terms here, that is cubed, you're going to write it 3 times, and then FOIL the first two, and then once you get that answer, you'll distribute it to the third. Or you memorize the pattern. Honestly, it's easier, I think, to write it down 3 times and just multiply them. Because the problem is, a lot of times when I used to teach this to Algebra 1, the students would get the patterns messed up. So you're better off just writing it down. If it's squared, write it twice and FOIL it. If it's cubed, write it 3 times and just multiply them. So let's try some examples. So if you notice on number 16, they have exactly the same numbers, but one has a plus sign and then the other one has a minus sign. So what's going to result here after I FOIL this is going to be the difference of 2 squares. What's going to happen here is the outer and the inner are going to cancel. So I'm going to go ahead and FOIL. Again, I'm doing first 4x squared, outer negative 6x, inside positive 6x, and then finally last negative 9. Notice when you have 2 binomials and one's a positive, a plus sign, and one's a subtraction, the outer and the inner cancel, and now I'm left with the difference. Difference means subtraction of 2 perfect squares. Again, you don't need to know the names. You just need to know how to multiply here. Next one, exactly the same thing is going to happen. I'll do first 16a squared, and then outside or outer will give me negative 20ab. Now, whenever I'm multiplying terms that have two different letters, I always write my variables alphabetically. It helps me to recognize like terms. So you may think, well, this should be positive 20BA, but if you put it in instead of BA, because that's what you're looking at, you're doing 5B times 4A, it's easier to recognize the like terms if you write them alphabetically. Yes. And then the last term on this becomes 5B times negative 5B, which gives me negative 25b squared. Again, notice the outer and the inner, like terms, they cancel. Final answer, 16a squared minus 25b squared. Again, the difference, subtraction, of two perfect squares. The next two are binomial squareds. Again, let me show you the common mistake, and I'm going to have somebody that's going to do this on the test on Thursday, and you're going to get it wrong. The whole thing's wrong because you're going to miss the middle term. Do not put the square on the 6x and tell me it's 36x squared plus 25. You get it wrong. You need to write it twice and FOIL it. Okay? If you don't, you're going to miss out on the middle term. If you don't want to write it twice and FOIL, memorize the pattern. So 6 times 6, 36x squared. Outer, negative 30x. Inside, negative 30x. And then finally last, positive 25. This has a middle term. It doesn't cancel. It becomes 36x squared minus 60x plus 25. So when you see a binomial squared, either memorize the pattern or write it twice and FOIL it. For number 19, same thing. I'm going to write it twice and I'm going to FOIL it. It's the safest way. I can show you a trick that I do if you'd like. 25, and then I'll multiply this, negative 40x. Inside gives me negative 40x. And last, positive 64x squared. Again, you've got a middle term here. 25 minus 80x plus 64x squared. Now, if it asks you to write it in standard form, you would put the 64 first, then the 80, then the 25. Either answer is acceptable, but just read what WebAssign wants you to do. All right, let's try the next one. Same thing. We're just going to write it twice and FOIL it. So 8x, let me do a different color so it shows up better. 8x plus 3 squared, so I write it 2 times. And I'm going to FOIL it. 64x squared plus 24x plus 24x plus 9. Combine the middles, 64x squared plus 48x plus 9. Now, for the cubes, you're either going to memorize the pattern or write it down 3 times and multiply them. Honestly, it's easier, I think, to do this. 3x plus 2, 3x plus 2, 3x plus 2. So what I'm going to do here is I'm going to first multiply these two. I'm going to FOIL them. This is going to give me 3 times 3 is going to give me 9x squared plus 6x plus 6x plus 4. Add the middles. And now I've taken care of these two, Now I need to multiply it with this one. Now, if you'd rather write it in front, you can. You could have left it the way it was. It doesn't matter. So now I'm going to distribute 3x to the 9x squared is going to give me 27x to the third. And then I'll distribute it to the 12, 36x squared. Distribute it to the 4. And now, again, instead of doing it all on one line, I'm going to put it underneath. Distribute the 2 to the 9x squared. Gives me 18x squared. Let me do it in a darker color. That's not showing up very good. 18x squared. Then distribute the 2 to the 12x. Gives you 24x. Distribute the 2 to the 4. And now I have everything lined up to add them. And I get 27x to the third plus 54x squared plus 36x plus 8. For the next one, I'm going to do exactly the same thing. I'm just going to write it down 2 times, and I'm going to FOIL 2 of them and then distribute the third one. So for number 22, x minus 2, x minus 2, x minus 2. So I'll go ahead and distribute the first 2. So x squared minus 2x minus 2x plus 4. So that was the result of multiplying those two. Still have this one here. I can combine these like terms. X squared minus 4x plus 4. Again, if you want to pull that last binomial in front, distribute. X to the third minus 4x squared plus 4x. So that is distributing the x to all 3. Now I'm going to distribute the negative 2 to all 3. Negative 2x squared plus 8x minus 8. Add them up. X to the third minus 6x squared plus 12x minus 8. And we're done. Couple. All right, so for this one, all we're doing is FOILing, even though we have a bunch of variables going on here. Now, at first glance, you may think these are the same binomials, one's a plus, one's a minus, but notice this has a square and this has a cube. So we got to do the whole FOIL. So we would do first, and this is going to give me 9a to the 5th. Then I'm going to do the outer, and this will give me 12a squared b squared. Then I'm going to do the 2 inside, and this will give me negative 12a to the third b squared. And then finally last will give me negative 16b to the 4th. Notice on this one, because the binomials didn't have exactly the same, there's no like terms here. This is my simplified answer. For the next one, all we're going to do is take them 2 at a time. Yes?
And that's in standard form.
And that would be in standard form. Now, you can choose, like on this one, when you got 2 different variables, you could have chosen to maybe pick one variable and put it in from greatest to least of that variable. For this one, it really wouldn't matter. You could have done it in terms of the b and put the negative 16b to the 4th first. Then I'd probably have done either the green or the red, and then finally the 9a at the end. For this one, it wouldn't matter. All right, last one, or not last one, second to last one. I'm going to FOIL these 2. This is going to produce the difference of 2 squares. So once I FOIL it, first gives me x squared, outer negative xy, inside positive xy, and then last negative y squared. Notice outer and inner cancel on this. So I'm left with x squared minus y squared. And now I got to multiply it with the last binomial here. And again, I'm going to FOIL it. So first, x to the fourth. Outside, positive x squared y squared. Inside, negative x squared y squared. And last, negative y to the fourth. Notice outer and inner cancel again. So my final answer here is just x to the fourth minus y to the fourth. All right, so the next instructions say to subtract. One, it says subtract this from this. So I'm going to write the second polynomial on top. And then I'm going to write the other one below it. So negative 7x to the fourth plus, and I can maybe shift this over so things are lined up. All right, now I'm subtracting this polynomial, the top one, from the bottom one. I'm doing my keep, flip, change. Keep this one the same, change this to plus, make all these signs opposite. And now I can combine my like terms. 9x to the fourth, nothing to add with the cube. I've changed the sign on the x squared, drop down the 4x, and the positive 1. So by doing that keep, flip, change, it made sure that my 5x squared was negative and my positive 1, or the 1, became positive in the final answer. And that is it for adding, subtracting, and multiplying polynomials.